Because I've actually seen applications where this makes sense to pull this out and do this, but this code itself was embedded inside of another method or another class. And if you refactor things cleanly, it's reusable. The whole point of object-oriented programming is to write clean, reusable, functional code so that you don't reinvent the wheel every time you do a new method, new class, new program. And if you break it down like this, it's very easy to understand what's going on and able to follow the bouncing ball.
Okay, gotcha. Okay, cool. Thanks.
This is, as Michael had mentioned as he started getting into this, is actually, you could do a lot of discussion around documentation and that. The approach that he's lined out is one approach. And it varies from organization to organization and even language to language, because some places it's things like it's entirely write your code without comments, so that there are no comments. It should be it should be readable based on like function names and class names and variable names and things like that. And some of it is even without having things quite as complicated, like the way this one's set up. For example, the subtract two numbers and return the result. If you look at the variable names, it's obvious that's what it is. I mean, it's like it's just take left number minus right number and it returns result. So the code itself is very readable, even with a very simple name. Now, some cases, the names, there are some languages limit the names. And some of them, some organizations are going to say, hey, we want to keep it, shorter rather than longer. Code completion makes it so that is less of an issue. Like personally, I prefer to have stuff within the comments as opposed to, having the name basically describe what it does. It can be like a summary, but usually have more in the comments versus, having real long variable names and things like that. But the point for all of that is consistency. And so he mentioned several times, programming standards, development standards. That is probably the most important thing, is that whatever organization you're in, is that everybody does it consistently, which is where things like code reviews are huge. So for example, if this is the standard and I go in and write it and I don't follow the standard, and I've got some X's and Y's and some things like that and some really short, cryptic names, then in the code review it would be something where Michael would be like, hey, according to code standards, this is how it should look. So, your code doesn't follow standard. Let's get that to standard, so that because that's the most frustrating thing, is when somebody comes in and looks at the code, and depending on what class or what file or what function even, it's completely different how it's documented. And of course, the other thing you have to watch out for is just make sure that it stays current. If you come in and you start changing something around, then you may need to update the comments. You may need to make sure that you've got your, maybe you adjust a couple of the names. So that's important. And then one other thing I wanted to point out that sort of comes up as Michael was going through that, where he was looking at, like where he's building out like what this does and what it returns, particularly like the divide by zero. That's something where it's important for both testing and then as you're developing it. So now it says, hey, we can't divide by zero. So you should either, have some sort of exception that it throws, or have something that says, okay, if I get a zero, I'm going to send this message or return this value, and then make sure that your code does that. Because from a testing point of view, that means, they're going to come through and they should be able to see from your comments, from your documentation, how that's supposed to work, and then build that test, and then it better match results. So if you say it's going to return not a number, then when they come in, if they do a zero, then it should come back not a number. Otherwise, they're going to say, hey, this failed testing. So documentation is a great way for you to be more thorough in your development. And that's why even in some cases, there's some approaches to coding where you start by creating comments. You pseudocode everything, and sort of write out the story of what your class or your function is supposed to do. And then as you build in the code, you've sort of got like an outline that says, hey, I got to do this. I've got to do that. I've got to check for these things and handle these exceptions. I've got to return these kinds of messages. So there's a lot of benefit that comes from proper documentation that is this sort of hidden, there's a couple of things Michael highlighted, but there's some things that was just sort of like, a part of that when you think about it, like, oh, wow, this is really going to help us become better developers doing it. One last thing I want to mention is that while this was focused on Java and JavaDoc, just like unit testing, the JUnit we've mentioned in the past, those tools exist in some way, form, or fashion in almost every language. And if you're not sure what it is, like, if you're getting into something new, then if you just do a Google or other search based on, hey, what is the JavaDoc equivalent in PHP or C# or whatever it is, then you're probably gonna get some good results. And yeah, the way that you do comments and maybe the way that you take advantage of that tool are going to vary, but those tools pretty much exist everywhere, and it's worth doing a little bit of upfront research to make sure that whatever it is you're working in, that you take advantage of it. And I guess the follow-up to that is things like Minify and things like that, and some of the code compilation types of things that work for example, with JavaScript, which allow you to have really big, complex names and all of that, and not be hurt by when you get to runtime, because it basically goes through and says, oh, I'm going to take all these big, complex, very human readable names. I'm going to turn them to something that is just, the machine can read it. A human's not going to get much use out of it, but then it's going to run faster. So, there's some tools like that, whichever environment you're in, it's worth it to understand what tools are there. And as an organization, or even as an independent, is to have a standard and stick to it and hold yourself and your teammates to it. I'll step off my soapbox, but there's just, like I said, this is one of those, it's a very big topic. And although Michael did a great job in one session, sort of saying, hey, here's some big differences from where he started and then where he ended up. There's so many rabbit holes we could go down talking about that.
Yep, and I have planned on possibly future topics and discussions on that as well, but good addition, Rob. Also, you mentioned code review. Well, right here, this is a good example of what should be caught in a code review if you document it. So here I'm saying what this method should be doing, and I say, oh, I'm done. I commit the code. Under code review, it should fail because I did not follow this condition. I did not do the divide by zero rule. So this would fail, this should come back, and then what should have happened should have been something more along the lines of, okay, so if right number equals 0, either return a number or like throw format exception or null number, whatever. But basically, you have to do something like this to handle that, like Rob was saying. The other thing that Rob mentioned that I didn't touch on too deeply, but if you actually were to, like I said, remove these comments, you understand what the code's doing. But if you haven't written this and you're just writing it for the beginning, this makes sense to just come in and write something, write the requirements for the method, write like pseudocode the method, and then even potentially after this, so you would do something like this. And actually, let's just do another example real quick. So if we were to do something like this, simulate the factorial on a calculator. And this is to calculate the factorial value of a number. Now, you get a number, so we could say float. We could say factorial. And we'll say float and number. That's it. All right. So we don't have to go too far into the depths, except we know we need to return something. So we know we need to return a float. Sorry, wrong float. All right. So float, and we'll just do return. All right, so this is just meeting the bare minimum requirements for the method. And then in here, we could essentially kind of do some pseudocode, or you could kind of write your testing. So you would say something like for testing, you could do something inside of here even, but for like a unit test, and this kind of pushes a different topic, but this is kind of where you would write your test-driven code. So you would write the test cases first and then come back and make sure that the code worked. But to test this, it would be factorial of, say, 0 would equal 0. I'll do it this way. Factorial 1 would equal 1. Factorial 2 would equal 2. 3 is going to be 6. And then for testing, basically factorial and factorial is going to equal to n times n minus 1. And so what you end up getting into is, oh, well, all right, here is how we're going to test this. This is how the function should work. So you would actually write this test case to expect these values, and then you would come back in here and you would write the code to do this. So actually what you're going to be doing here is if number equals 0, return 1, else return factorial minus 1. And it's 0. So now what we've essentially done is to meet this criteria, we are checking the number to see if it's 0. If it's 0, we return 1. And then, so if we start out with 0, factorial of 0 should be, if 1, return 1. I'll change the criteria just for simplicity for right now. So if we're 1, we return 1. So 1, yeah, no, 0 was right. So if we're 1, 1 minus 1 is 0, 0 comes in. If we're 0, we return 1. If we're 2, 2 minus 1, okay. What am I doing wrong here? Something.
Number times the factorial.
Thank you. Or well, yeah. Right. Something like that. But anyway, so this is how you would write recursion. But here's your test case. So you would actually write this test, and then the test would exist. So you would expect 1, 2, 3, and so on. And then you would come in here and write your code. So if your code worked, you would run the test and you should get these test cases should pass. So that's just kind of pseudocoding and expanding out on that. But if I didn't do that, or like this division by zero here, like this rule, code review should fail, things like that. So this just is, like Rob said, one example of how you can do readable code. I just like this particular approach because with the comments, it's very clear. Without the comments, it's still pretty clear as to what's going on. And this can be applied to pretty much any language out there, not just Java. Any other questions? Okay. So today we talked about writing readable code. We talked about ways we could cleanly write code, why it's beneficial, what can happen if we don't write readable code, and just some other rabbit holes we could go down if we expand on this topic further. I'd like to thank everyone for your time today. We appreciate your time. If you'd love to discuss any of these topics further with us, you can reach out with some questions or comments to us at info@developerner.com, developerner.com/contact us. We're on Twitter @developerner. We're also on facebook.com @developerner. And you can find us on YouTube by searching developerner. Our goal is making every developer better. Thank you. Have a wonderful day.